Hello students, here is our fourth technical document. In this document, I'm going to show you how to draw a climate graph. Remember that the climate graph is simply the representation of our two variables, the temperatures and the precipitations. We are going to consider here the monthly mean temperatures and the monthly totals of precipitation. So, we consider the mean temperature of January, February, March until December, so 12 values, and the totals of precipitation for January, February, March until December, so also here we're going to have 12 values. And a climate graph is simply a combination of two types of graph, the line graph and the bar graph. Just remember, the biggest mistake that some students make when they draw a climate graph is to use the incorrect type of graph. So, if you remember this, you will do it right. The line graph always represents the monthly mean temperatures, and the bar graph always represents the monthly totals of precipitation. So here you have an example of a climate graph. This is the climate graph of Uccle in Belgium. So you clearly see the climate graph, and at the bottom of the slide you also see a table, a set of data. So for each month of the year, you will have the monthly totals of precipitation and also the monthly mean temperatures. And this is what you need to use to draw your own climate graph. Let's have a look at this climate graph. We clearly see it's a combination of a line graph representing the monthly mean temperatures and the bar graph representing the monthly totals of precipitation. Let's have a look at the line graph first. So for the month of December, you see a dot, which is in the middle of the month, by the way. And this dot represents the December mean temperature, so 3.1 degrees Celsius. And if you have a look at the table at the bottom of the page, well, you will see that for December, you have indeed 3.1 degrees Celsius. Let's analyze the bar graph now. If you have a look at this graph, you will see some bars, and those bars represent the monthly totals of precipitation. You have the example of January. This bar represents 68 millimeters of precipitation. So this is exactly what you have in the table below. So now I'm going to show you how to draw your climate graph. Remember, there is an official way to draw a climate graph, and I truly advise you to follow each step of the process so at the end you end up with the correct and precise climate graph. So I always provide the appropriate sheet of paper, but remember, for the y1 axis, 1 centimeter is always equal to 1 square. Same thing for the y2 axis. And same thing for the x-axis, but for the x-axis, 1 month is equal to 1 square, so 1 centimeter, and your graph will be maximum 12 centimeters wide. Before drawing your bar graph and your line graph, well, you need first to prepare your axes and graduate them properly. So let's have a look at the x-axis first. The x-axis represents the months of the year. So you will have 12 centimeters for 12 months. And then you have your two y-axes, y1 and y2. y1 will always represent the monthly mean temperatures, and y2 will always represent the monthly totals of precipitation. And of course, let's not forget the title. Well, you will always have to write a title on top of your graph. So the usual title is Climate Graph of the City we will study together. Step number 2, now you have to graduate your 3 axes. But please remember, always use the following scales. For the y1 axis, so the axis representing the monthly mean temperatures, 1 centimeter or 1 square is equal to 10 Celsius degrees. For the y2 axis, it's a bit more complicated. So 1 centimeter represents 20 millimeters of precipitation, but only between 0 and 100 millimeters of precipitation. Beyond 100 millimeters of precipitation, well, 1 centimeter represents 100 millimeters of precipitation. The relationship between the two y-axes is therefore P is equal to 2Tm. It's going to be more obvious on the next slide where you see the two axes and this relationship on the two axes. For the x-axis, well, it's quite simple. 1 centimeter is simply equal to 1 month. Now that we have our correct title and we have our three axes, we need to properly graduate them. So let's start with the x-axis, the axis of the month. So here it's quite easy. We have 12 centimeters, 12 months. So we're going to graduate our axis with each month. So each letter will be placed in the middle of the square. So it's time now to graduate our y1 axis representing the monthly mean temperatures. Here again we work by centimeter or square. So 1 centimeter is equal to 10 degrees Celsius. So we graduate our axis 10, 20, 30, 40. We can stop at 40, even 50 degrees Celsius. Let's now graduate our y2 axis. Remember, the y2 axis will always represent the monthly totals of precipitation. So there is something important here. You always have to remember this relationship between the two y-axes, y1 and y2. So P is equal to 2Tm. Knowing this, P is equal to 2Tm, you're going to start your graduation with 20, as P is equal to 2Tm. 10 times 2, and then 40 millimeters, 60 millimeters, 80 millimeters of precipitation, 100 millimeters of precipitation. So you clearly see the relationship here, P is equal to 2Tm. But if you have a look at this graduation, you see that there is a trick. There is a change of scale. So from 100 millimeters of precipitation, you have to go directly to 200 millimeters of precipitations, and then 300 millimeters, 400 millimeters of precipitation. So why do we have this change of scale? Well, simply because in the world you have tropical climate areas. And in those tropical climate areas, there are high levels of precipitation. For some months, you can have like 300 or 400 millimeters of precipitation. So to make your graph easier to understand and also analyze, we have that change of scale to accommodate any kind of climate. We're now ready to draw the climate graphs, and I'm going to start with the line graph representing the monthly mean temperatures. And for this, I'm going to use the climatic values that you have on the previous slide for Uccle in Belgium. So if we have a look at the climatic values for Uccle in Belgium, we see that for January, the monthly mean temperature is equal to 1.9 degrees Celsius. And simply we draw a dot at 1.9 degrees Celsius. We do exactly the same for February, March, and the other months of the year. And until December, of course. Remember, for December, we have 3.1 degrees Celsius. And if you have a look at this graph, this is exactly what we have. All right, let's draw our bar graph now. So we consider the climatic values for Uccle again. And for January, you can see in this table that you have 68 millimeters of precipitation on average. So let's draw 68 millimeters of precipitation. We simply draw a bar, and this bar represents 68 millimeters of precipitation. To do so, remember, you have to consider the y2 axis, not the y1 axis, but the y2 axis, the one representing the monthly totals of precipitation. So you do this for January, February, March, and the other months of the year. And this is it. This is our climate graph of Uccle in Belgium. So here you clearly see the combination of a line graph and a bar graph. Now I'm asking you to do the exact same exercise for another city and other values that you have in your course. If you follow the different steps properly, if you graduate your axis properly, well, I think there is no way you do it wrong. So good work, everyone.